Good morning, everybody. We're here today talking about pressure pipes for the Eastern Oregon Operators Conference Short School. My name is Brandon Mahon. Today, both Lucas Stangel and I will be presenting on this topic, talking with you a little bit. As we get started here, we've got a PowerPoint that I'll share in just a minute. Try to work through the technology here. A little bit about us. My name is Brandon Mahon, as I mentioned. Been with Anderson Perry for about 8 years now. Mostly work with water, wastewater. Went to school at Oregon State. Grew up in Wallala, so home is Northeast Oregon. So yeah, hopefully we can give you a little bit of information here, and I'll let Lucas introduce himself.
Yeah, I'm Lucas Stangel. Been at Anderson Perry for about 5 years. Worked at CH2M Hill for about 5 years before that. All the experience has been mostly in water, wastewater treatment. Do some irrigation work. I also, like Brandon, went to Oregon State. A little different than him, though. I got a mechanical engineering degree instead of civil. But I'm also from Eastern Oregon. I grew up in Enterprise and am actually been working out of an office in Enterprise for Anderson Perry about 3 days a week, and in LeGrand 2 days a week.
Awesome. So in this new age we're working in, we're working through this Teams meeting. I've got a PowerPoint slide we'll go through here. Lucas, you can see that, can't you?
Yep.
Okay, great. So again, like I said, we're talking about pressure pipes today. Obviously, a lot of you operators, between water systems, your wastewater systems, if you got a lift station and a force main, you deal with these every day. So we'll get started here.
All right, so yeah, I'll go over some terms and definitions of some of the pipe and stuff related to some of the pipe that we'll be talking about today. PVC, pretty common, stands for polyvinyl chloride. And then a kind of offshoot of PVC is PVCO, or molecularly oriented polyvinyl chloride. HDPE, high density polyethylene. Then some of this pipe uses DRs and SDRs that kind of go with the pressure rating or the wall thickness. You guys may want to kind of pay attention to this, but DRs and SDRs, that's calculated by the average outside diameter divided by the minimum wall thickness to give you that ratio. Then there's pressure class, which would typically have a factor of safety of 2.5 rather than the 2.0 used in design. And then pressure rating is the factor of safety of 2 used for design purposes. Some of the wall, kind of like the DR, SDR, some of the pipe is provided in schedules versus the DR, SDR. Common are Schedule 40, Schedule 80. With scheduled pipe, the OD is the same for whatever size of pipe, and as you get higher schedules, the walls get thicker, so the ID gets smaller. So you have smaller area for the actual pipe flow.
Perfect. So some common pipe types, and again, I wanted to give everybody a caveat. Lucas and I, we're just lowly engineers. We're not pipe representatives. We're not pipe manufacturers. So we use a lot of this stuff and specify a lot of this stuff, and have seen it on construction sites and worked with contractors and operators. But a lot of this stuff, if you have questions, the experts are really your pipe suppliers and the folks you ought to go to. We can definitely help, as far as field installation and some kind of gotchas that we've seen, especially here at Anderson Perry. We're dealing with a lot of this, but I encourage you to talk to your suppliers, and if you have other questions or concerns about what you're trying to do there. So And the other thing, we'll talk a little bit about it, but just so everybody in this meeting's aware, the PVC and the plastics market in general is just super volatile right now. So some of the things we'll talk about later, especially when we start talking about availability and cost, just keep that in mind that as you're working through projects right now, it's kind of a crazy market we're in. So anyway, just want to give that little caveat that make sure that what we're talking about today is pretty high level. So if there's some more details you need, be sure to reach out to your pipe representatives. So some common pipe types that we see in our industry, talking about municipal water and wastewater, obviously PVC, probably the standard that we see mostly in water and wastewater. Lucas mentioned in the past slide, PVCO, that molecularly oriented polyvinyl chloride. That's come up a couple of times in projects, at least for me recently. It's not as common, especially not in our region. We've had some contractors that have proposed to use it on projects as a substitute for C900. It's same material, same resin, it's just how it's constructed is a little different. So my understanding is, like a C900 pipe, if you've got an 8-inch pipe and it's, they mold it and there's a certain thickness, the C909 or the molecularly oriented PVC, they essentially take that same 8-inch pipe and they blow it up with air to make like a 10 or 12-inch pipe. And so just imagine like blowing up a balloon, that wall thickness gets a little thinner, but when they do that, it essentially changes the strength characteristics. So again, I don't know if you guys on this call, if any of you have used that before. Not as common as contractors have proposed to use it. And we've talked to pipe suppliers. They've kind of noted that, yeah, we know about it, but we haven't really used it in 20 years, but it's been around for quite a while. So HDPE, we got a picture of that down here in the lower left-hand corner. We use that every so often. It seems like, if we're crossing like under a river or something, that's kind of a popular one at times. Long transmission lines, we'll talk a little bit more about that in a little bit. Ductile iron's one we see often. I know some cities that's their standard. They haven't gone to PVC. They use ductile iron as their standard. And then the last one we got on here, fiberglass reinforced plastic. Seems like we see that every so often. I know Lucas has worked on a couple projects with it. I think it's definitely more common when you get into larger diameter piping. So first, C900, the goal for today is to kind of go through some of these pipe types and talk about applications. Between Lucas and I, maybe we can share some war stories with you. Talk about some design considerations, and then, like I mentioned earlier, a little bit about availability and relative cost. Again, like I say, that it's kind of all up in the air right at the moment. So as we're recording this, I'm not sure pipe prices might double by the time you actually watch this, but kind of just briefly go over those. So C900, like we mentioned, kind of the current standard that we see a lot of. It's got a DR pressure rating. There's multiple, DR18, DR25s are ones that we see most often. I think our standard spec, we typically use DR18. I want to say it's like a 235 PSI pressure class rating. As far as the specification goes, the current one is C900-16. There is no C905 anymore. I think in the 2016 update to the AWWA specs, they combined the two. So you used to have C900, which covered, I think, like 4 to 12 inch, I want to say. And then if you got bigger than 12 inch, it went to C905. And so with that, the most recent update, it's all combined into C900-16. So if you're looking for the latest AWWA spec, point there. And then, as you guys know, just a note, there's obviously a color coding system to where, your water distribution systems, you got the blue pipe, for sewer force mains, green pipe, and then if we have reclaimed water, I know if we have like an irrigation system where we're coming out of a lagoon and we're going to an irrigation site, that pipe is purple. So anything to add there, Lucas, for PVC pipe?
No, I think you covered that pretty well.
So design considerations, like we mentioned, it's available in 4-inch to 48-inch. Size availability depends on the DR you're looking for. Again, not being pipe suppliers, I know there's been times where I think the term you hear them use is block pipe. And so that's kind of your standards, your 8-inch or 12-inch at certain DR ratios. If you start getting into kind of unique sizes and unique DR classes, that's more of an order pipe, a quote pipe that they have to make special for you. In general, PVC's got cast iron OD, and so as you're talking about fittings and valves and getting this pipe to marry up to other materials, just keep that in mind. 20-foot lang lengths typically. So again, that's their standard. I know working with like the city of Baker City, working on their mountain line, the construction of that is a little bit unique as far as where we're at in the world, and so in order to facilitate a little bit easier construction, we've specified shorter pipeline lengths, and so they come in 14-foot lengths. There are some instances where the pipe suppliers have some little bit different testing if you get away from the 20-foot lang lengths, but you can get it in different lengths ordered that way. Typically, the bell and spigot joints are used. That's what you typically see from the manufacturer. There are locked-in gasket type joints that you can specify. And then also special gaskets can be used with different liquids, such as petroleum and maybe some of those harsher chemicals. I don't think too many folks in this room will run into that, but something that is available. Some more design considerations for C900. Connection to different types of pipe can be done. They've got different fittings and transition couplings. Generally, they're pretty readily available. There's plenty of times where folks are, especially on a little bit older systems, you may be tying into some existing AC pipe, or you're laying new pipe and need to, transition into the existing pipe. So there's definitely fittings available for that. And then same story for fittings and valves with that cast iron OD, different pipe types and different, as your PVC comes in, you can marry up to those different fittings and valves pretty easily. Some more considerations here. As far as kind of an installation note, changing direction of pipe. There's a lot of times you're, installing pipeline and you don't necessarily need to install a fitting. The deflection isn't a lot, but you need to change your alignment just enough. Typically, the preferred method is to deflect the pipe barrel. Actually, try to take that pipe and bend the pipe itself rather than doing it at the joint. Especially in higher DR classes, or I'm sorry, lower DR classes, thicker pipe and larger diameters. That's pretty tough to do. It's not real flexible pipe at that point. So it is. The manufacturers do allow you to get some deflection at the joint, but they limit you there. Obviously, you can imagine you've got that rubber gasket in there. If you deflect too much, it kind of creates a pressure point there in a place where you could get leakage. So typically in our master specs, we try to get folks to get the bending in the pipe barrel and not the joint, but typically, I think the manufacturers will give you up to about a degree with PVC pipe of deflection at the joint. Like we talked, PVC pipe is generally readily available. Again, at the time of this recording, things are a little crazy, but some big manufacturers, you got JM Eagle, Diamond, there's others. As far as our local region here, there's manufacturing as close as McNairy, Oregon. JM Eagle has a manufacturing facility over there out of Umatilla. And again, the cost, typically as compared to other pipe types, it's usually a little bit on the cheaper side. compared to like an HDPE. It's usually fairly comparable. Generally, it's cheaper than ductile iron, but again, with everything going on in the world, I know the Texas weather events that we've had over the last month or two, a lot of the refineries that are creating the actual resin that makes the pipe are in the Gulf area in Texas, and so I know that's put a real hamper on supply and being able to get materials to the manufacturers to actually make the pipe. So at this time, cost is a little bit volatile. And then again, just a quick note, we talked about this a little bit earlier. C905 is no longer really specified, so it's all in that C900-16 spec. So. C909, again, that's that molecularly oriented pipe. It's generally used for water distribution. It's also available for sewer and reclaimed water. Like I say, we haven't spec'd it. I don't, to my knowledge at all. I don't think it's as common. Again, I think there's probably applications for it, and there may be regions in the nation where it's used a little bit more regularly, but financially it's not a lot different in cost. Here we go to the next slide here. So the hydrostatic design basis, so the kind of the pressure rating, what it can take, is higher than conventional PVC. It has the same cast iron OD, and so it's in order to get that, you've got a thinner wall. And so standard 20-foot laying length, just like C900, balanced spigot joints. The thing that we've run into that has kind of caused some concern for us on other projects is we had some restraint that we were trying to put on, and so there's some information out there that there may be concerns with different restraint types. I mean, you can imagine this pipe is a little bit thinner, potentially a little bit more brittle, even though it has a higher design pressure rating. So there could be concerns with some restraint there. And then availability, again, like I said, it's similar to C900. I don't know. I mean, they can manufacture it, I think, just as similarly as they can to C900, but again, it's typically not as common. And as far as cost, it's comparable to C900. I think at times you can get it a little bit cheaper, but I think, again, that kind of depends on the market and where things are at there. So that kind of covers PVC. Lucas, is there anything else you want to add before we move on to HDPE?
No, I don't think, not on the pipe. I think we can get into fittings and some stuff that we use with PVC. I think that's later in the presentation. So
sounds good.
Yeah. All right, I'll talk about HDPE. So there's generally two standards for water service HDPE pipe, C901 and C906. The C901 standard covers basically your small diameter pipe, so anything 3 inches and smaller. The C906 is basically bigger than that, 4 inches up to, I think, about the max is about 65. Seems like they come out with larger pipe diameters every once in a while. But both those standards have different types of resins or grades of resins. The two most common are the PE 3608 and the PE 4710. The 3608 used to be the common one, and this 4710 is a little newer. It's been on the market for quite a few years now, but it's generally it's a stronger resin. It has a higher tensile strength and density. The resistance to cracking is greater. So yeah, I think it's becoming more the standard to spec these days compared to the 3608. HDPE joints, it's not really on this slide, but typically all the joints, or what we spec is that they fuse together using a fusion welding machine for all the pipe-to-pipe joints. There's fittings, and we got it here, but we can talk about it a little later too. But generally, there's molded or fabricated fittings for your 90s and T's and elbows. And then if you want to transition to a different connection type or pipe type or valve or whatever it is, you'd usually have to fuse on an adapter to make that transition. Something also similar like PVC, HDPE, you can get it color coded. It's a little different though than the PVC where the whole pipe comes as blue or green or purple. The HDPE usually just has stripes down it, but it can be provided with that color coding to differentiate the water from the sewer to reclaimed water or whatever other processes you may have. All right, so then kind of just go through some applications. There's, the municipal industrial market, drainage for stormwater, sanitary sewer, water distribution. But yeah, so like in the municipal industrial market, really common for underground installs. Your transmission lines or bores underneath a highway or railroad lines or whatever it is. Then yeah, you can use it for drainage, stormwater, culverts, sanitary sewer for gravity or force mains, boring there too, water distribution. Yes, I haven't touched on that too much. We use HDPE for service lines quite a bit, coming off the main lines on your water distribution systems. So from the main line to the meter base, it's kind of become, for the most part, our standard, at least in our specs, to use that smaller diameter, the 1 inch, 2 inch HDPE that can come in rolls versus just in sticks of pipe. It's used in irrigation quite a bit. Rehabilitation, you can slip line this into existing pipes if there's an old steel transmission line that digging it up and replacing it's gonna cause issues or difficulties. Can slip the HDPE in to reline it and rehab your existing pipes. Used all over the place for a lot of different applications. And it is available in iron pipe size and ductile iron pipe sizes. The IPS is the most common, I believe. It's what most places use. Some design considerations. A lot of it's 40 to 50 foot lengths. As I mentioned, the smaller diameters, 6 inches and smaller, can be extruded in continuous rolls. Typically lower DR ratios compared to PVC with thicker walls for the same pressure rating. Standard HDPE, I guess, or most of them, you have DRs from 32.5, which is has a pressure rating of 51 psi down to a DR of 7, which I think is a little over 260 psi. The nominal size is based on the OD of the pipe. So as your DRs increase or decrease, so the smaller DR, higher the pressure rating, your wall thickness increases and your ID gets smaller. And with some of those bigger pipes, there's quite a bit of difference. Just as an example, like a 12-inch DR7 pipe, 12 inch is, the average ID is a little under 9 inches. So that's something to really pay attention when sizing pipe. If you have a certain flow and PVC or ductile iron, a 12-inch pipe would work. You may need to jump up to a 16 for high pressures. in HDPE. Kind of already talked about the sizes. Yeah, generally we can go from, sorry, airplanes flying over. Yeah, from about 1/2 inch or 3/4 inch up to 63, 65, somewhere in there. And as I mentioned before, typically all the joints are heat fusion, electrofusion. There are some, there's socket or electrofusion type of fittings that we'll get into later. But for the main pipe joints, the preferred and common way is to use the electrofusion butt joint. Yeah, I guess I was getting ahead of myself. We already talked about that IPS and the iron pipe size and ductile iron pipe sizes.
Yeah, I think just to add to that, Lucas, a couple things as you were talking there. I know in talking to the pipe suppliers, most of these plastic pipes are really based on just the cost of the resin. I mean, that's kind of what drives the price of it. And so, like Lucas was saying, if hydraulically you get to a point where you're kind of on the cusp of needing to go up to an additional size in HDPE, that can really make a difference between kind of that cost analysis between like a PVC or an HDPE, because again that wall thickness gets pretty hefty. And then the only other thing I was going to mention about HDPE that I've run into on a project, more of a construction consideration than a design consideration, but we had a sewer force main out in Cove, and the contractor was, putting the butt joints together. He had his trench excavated and was putting in long runs, hundreds of feet long, putting pipe together. I think something kind of unique to HDPE, a lot more than say like a PVC, is that it'll walk on you. That pipe will expand and shrink with temperature change. It's pretty sensitive to that. And so we just had to be cognizant of, getting it in the trench and buried before, especially in, Northeast Oregon and Eastern Oregon, we can get kind of cold nights and hot days. And so just something to be cognizant of, usually not a huge deal, but just something worth mentioning.
Yeah, and I guess I'd add to that, previous stuff I've worked on some HDPE where you're coming up above ground, connecting to valves and different things. And so that's something, if you happen to have, coming up to, I don't know, I'm not sure what we'd have on the municipal side, but some type of valve or something coming up above ground and you're using HDPE, you got to pay attention to those temperature differences and the forces that can apply onto the piping, and provide adequate thrust restraint, usually with some sort of collar right before it comes above ground so it doesn't pull on whatever you're connecting to. That makes sense.
Perfect.
So yeah, availability, and I guess actually I just saw something else. Not really a design consideration, more construction. Some of that small or higher DR, lower pressure rating, HDPE, got to be careful during the install. You don't want big rocks and stuff in your trench. It can be, punctured fairly easily, or not easily, but if you have your bedding material, I guess just need to make sure that it's, the right stuff to be using and not having any big 4 inch or larger rocks in there with your 3/4 minus or whatever you're using. So yeah, availability, like we said, IPS is kind of the main size, so it's readily available. You can get the ductile iron pipe size, but probably not sitting on people's shelves. Similar for the fittings too, IPS versus DIPS. The DR11s and 17s are the most common and readily available. Would like to know, we've ran into some projects lately on the availability. If For the kind of more standard sizes, I'd say probably like 12-inch and under, it's probably not a big deal. But once you get above that, if there's not pipe sitting, in somebody's yard somewhere ready to go, sometimes it's tough to get it unless you are doing like a big run. We did a project where we only needed I think it was like 200 feet, but it was some larger diameter, and nobody had any, and none of the plants wanted to start up and do, tool up for a run of 200 feet. The cost of tooling and everything made it that much more expensive. So either if you do have short runs of, larger pipe, hopefully somebody else in the world needs some too, so they can run it all at once. Or yeah, maybe difficult. Cost similar to PVC. Right now it's pretty volatile. Like Brandon was saying, the kind of oil prices and the weather in Texas and everything are kind of just making this market go a little crazy. Not sure what the prices are right now. I guess I've been hearing that it's hard to get quotes for PVC and HDP right now, and if you do, the quotes are usually good for 24 hours. So it's making it a little difficult to bid jobs and stuff right now, but hopefully that changes here before too long.
Yeah. I think for most operators, probably on this call, just for your standard kind of water and sewer, you probably won't run into a lot of HDP. It seems like, Lucas, the projects we see mostly, the ones that I'm thinking of anyway, real long transmission lines. I know we've had like some hydro projects, especially when you're up in the mountains. Looking back at that picture of it, I don't know if I can go back to that. Kind of long, snaky alignments. Down here in the lower left, it's pretty useful for that.
Yeah.
And then, like I mentioned, as far as like a bore under a stream or something, when they fuse those joints, it's pretty impressive. I've seen testing videos that once they fuse that joint is actually stronger than the pipe itself. And so when you start yanking a bunch of pipe through a casing under a river or something, it's usually a pretty good option for that, just because those joints are so strong. So okay. Next, we'll talk a little bit about ductile iron. As far as applications, it's generally used when you got real high pressures, heavy loads, unsuitable trench conditions are expected. Again, like Lucas was talking about with your HDPE or even your PVC, if you start getting your bedding or your backfill large, sharp, big rocks, if you're nicking that stuff, over time, you may not puncture a hole in it right now, but over time with those pressures, you get a little bit of movement in pipe potentially. You can kind of wear a hole in those. So if you're in an area where you're concerned about that, ductile iron's a good option. Heavy loads, a lot of times if we get pipe installation where we're unable to get the amount of cover we really want, a lot of times we'll put in some ductile iron. It can also be used for gravity installations, especially like I just mentioned in those cases. If we're concerned about cover, we can use it there as well. Design considerations, available in 4-inch to 64-inch. There's limited availability, kind of in the smaller diameters. One thing with ductile iron is there's a lot of different joint options. There's kind of your standard bell and spigot. You can get MJ joints. There's restrained MJ joints, at least a couple different types. There's restrained gaskets. You can get just flange ductile iron. So there's a little bit of flexibility there in the ductile iron world. The OD is larger than nominal. So like a 30-inch ductile iron, the OD is 32 inches. So something to think about there. Again, with ductile iron, there's a little bit more flexibility according to the manufacturers as far as the deflection at the joint. They recommend a maximum of 5 degrees, so a little bit more flexibility there. And obviously your At least I'm not going to be bending the barrel of a ductile iron pipe, so got to have some flexibility there in the joint. Some more thoughts on ductile iron, some potential concerns. You know, they typically come coated, so especially for underground installations. But if you have really corrosive soils or hot soils, I know we have some clients in the area that have some issues with that. Typical installation, they recommend you put in, you bag it essentially. If you've heard that term before, put in pretty much an 8 mil poly encasement. Pretty much just black plastic bag essentially, which is intended to help with keeping that corrosive soil from eating away at your ductile iron. As far as the linings and coatings, the linings, so in the interior of the pipe, you've got kind of the standard cement mortar as kind of the standard spec that we use, and then you can also get an epoxy coating or lining, excuse me, on the inside of the pipe. And then as far as coatings for the exterior, again, the standard is kind of that asphaltic coating. You see it in black, especially for buried pipelines. And then you can also get epoxy or urethane paint if you're using a ductile iron more in, say, like a pump station application. That pipe will come from the factory just primed, shop primed, and then typically get painted in the field.
And then I guess some just to add there, kind of on the coatings. The cement mortar lining's typically a good choice for, I guess, not coatings, but the linings. It kind of has the ability that if part of it gets dinged up or anything, the flow of the water or sewer, whatever, inside the pipe will kind of push the cement mortar lining that's upstream of it and can kind of fill in the any damaged areas, I guess. So that's kind of the go-to lining, unless there's some other reasons to do something different.
Right. Perfect. So as far as availability, you got different pressure class pipe, and it's generally more readily available than thickness classes. So I know, and this has kind of changed a little bit, I think, throughout the past, but some folks talk about pressure class, some folks talk about thickness class. Your thickness classes, if you hear somebody talk about like class 51 or class 52 ductile iron, that's a thickness class. I don't think pipe suppliers or manufacturers produce and talk so much in thickness classes as much as they do pressure classes anymore. Generally, at least to my knowledge, again, not a pipe supplier, but I typically don't think it's produced in the Pacific Northwest. I think most of your ductile iron's made back east, and again, I think in Texas has kind of some larger pipe manufacturers, but still pretty readily available. And then again, cost, generally it's slightly more than PVC, but depends on the market. I know not all that long ago, just kind of getting this secondhand, talking to an engineer the other day, with what the PVC prices are doing now, there was a time not all that long ago that PVC markets got a little volatile like this, and I think we had a project in Boardman that we did a bid option and bid both ductile and PVC, and ductile iron was actually more competitive. So again, there's kind of the standard, but there are times when market conditions warrant taking a look at both, and potentially might be able to get ductile iron at a little bit better price. We'll talk a little bit more about restraint later, but that's one thing to note with ductile iron is there is a little bit more flexibility there. Or, flexibility may not be the right word, but a little bit less cause for concern when we get talking about restraint. Again, some folks, this is just their standard. I know we have cities here locally that for distribution main lines, that's what you use is ductile iron. So definitely has some pressure benefits, and then durability, like we talked, as far as trench conditions, is another benefit there. So, anything else on ductile iron, Lucas?
No.
All right, move on.
All right, I'll talk just probably real quick about fiberglass pipe. Most of the guys on here, you guys probably haven't dealt with it or seen it too much. Lately, there's one company that's kind of been trying to push it more in kind of this region, but I've been seeing it more on like irrigation projects and stuff like that, where there's larger and longer runs, but could be an option for, kind of your transmission lines as a kind of alternative to HDPE like we've talked about, or if you have any really high pressure systems. But yeah, so fiberglass reinforced plastic or FRP, you can get it for pressure or gravity piping systems. It's used in all sorts of applications: water, wastewater, stormwater. Non-corrosive. You can put it in the ground and it's going to be there for 100 years probably. That's, I guess, one of the main benefits of it, because typically where I've seen this, it's more of a competitor with like steel pipe, and that's kind of the real benefit of the FRP, is that you don't have to worry about coatings or cathodic protection or anything like that. Some design considerations. Generally available 12-inch to 160-inch. I think you can get it smaller, but not as common. The joints are typically, they use a double bell coupling, so basically just a coupling that has a gasket right in the center that both pipes butt up against, and then a gasket around the pipe on each side. When you get into restrained areas, they'll laminate the joints, so they actually go in and lay fiberglass down to basically to join them together using a laminated fiberglass process. Like the other type of like ductile iron and stuff, you can deflect the joints, but that varies based on pipe sizes. The larger the pipe, the less you can deflect it. It's UV resistant. Restraint, kind of talked about that with the laminated joints, but it usually requires thrust blocks or laminated joints, or I've seen where they will transition to like a welded steel pipe and have enough pipe between the two non-restrained joints that before the elbow to restrain the whole thing. And yeah, like I said, not really competitive until you get into the larger pipe sizes or higher pressures, or a combination of both.
So just to put a plug in here, Lucas just did a big project for an irrigation district over Umatilla County. How big was that pipe, Lucas?
So yeah, there was it's like a 7-mile long pipeline, and half of it was 72-inch diameter and half of it about was 75-inch diameter. And we bid options for steel and FRP, and sometimes it kind of depends on the market. We were actually assuming that the steel was going to come in lower, but the fiberglass came in, and so that's what we ended up doing. But it had a combination of steel and fiberglass. But yeah, over kind of the Boardman area, there's been the last couple of years through irrigation districts and the Port of Morrow and stuff, quite a bit of fiberglass pipe going in.
Yeah, it's not every day you see a 6-foot pipe go on the ground, so that's impressive.
And it's not as readily available. It's usually you gotta, custom order it, or they don't have a lot of it sitting on the shelves. Most of it comes from overseas. I guess the one main manufacturer is getting a plant, trying to get a plant up and running in Texas. But there's one company that I'm most familiar with. They have partners overseas, and South America and all over the place. So depending on what's going on in the world, it's, usually the price is more stable, because if there's a problem in one area, they can go to their plant somewhere else. So But yeah, so I know they have used it, I guess I'd say more in like wastewater applications, in corrosive environments for I'd say larger cities and where the pipe sizes get big. But yeah, haven't seen too much of it on the municipal side in our region.
Okay. So next we're going to talk a little bit about pipe fittings. Up till now we've talked mostly about pipe, obviously, and going to transition a little bit into the fittings that you're going to need for installation of each one of these pipe types. So, the main ones we're going to talk about today: ductile iron fittings, HDPE fittings, which are kind of a different animal, FRP fittings, like Lucas was just talking about, and then some of the ones that you guys are probably using every day, at least pretty familiar with, as far as kind of a dresser style coupling, some Foster adapters, flange coupling adapters, dismantling joints, and then we'll talk a little bit about restraint. So ductile iron fittings, commonly used for both ductile iron and PVC pipe, and so you can use them for both of those. More readily available than PVC fittings, and a little more common, I would say. You can get like an actual PVC fitting, generally a molded fitting made of PVC for PVC pipe. Probably the one benefit of those is I think they're more of a custom order. You can get, if you need an 18-degree joint, you can get that made, but I think they're typically a little bit more expensive and like I say, not really readily available. The ductile iron fittings, you can get both mechanical joint and flanged. They're available in compact and standard, full body fittings. We typically use compact fittings, usually take up a little less space. And then as far as the pressure rating, you just want to make sure that the joint and the fitting, the pressure rating matches the adjoining pipe. So you don't want 250 class pipe and a 100 class fitting to where you're, causing a weak spot in your pipeline there.
All right. HDPE fittings, kind of touched on it a little bit. They usually provide molded fittings for the smaller diameters and fabricated fittings for the larger. So the molded, I think typically use like an injection molded, so it looks like all one piece, and the fabricated look like they took a bunch of pipe and fabricated it together. Then yeah, I used adapters to transition to whatever you want. They have, flange adapters or MJ adapters or smaller stuff. You can go to a threaded pipe adapter and you can do stainless steel or PVC adapters, basically any type of adapters you want. They do have the electrofusion, which maybe is that on the next slide?
Yeah.
So yeah, they're kind of like we talked about. There's the butt fusion. That's that machine on that lower picture. There's a hot plate, or you stick the pipes in there. It trues them up, the ends up. Has a hot plate to warm up the two ends, and then presses them together. That's the preference for, I guess, fittings, joints, everything that provides, the best joint. But there is electrofusion, which was, go back to that previous slide. That picture on the right, that's an electrofusion elbow. Those two little, I guess, looks like pipes sticking up off there. Those are connections to hook up to the electrofusion machine. So you can slide your pipe in there. Then there's basically wire wrapped around in there, and you hook your machine up to it, and that wire gets hot and fuses the pipe and the fitting together. See that more often on kind of like saddles and stuff onto existing pipe, because yeah, the butt fusion I think provides a better or more reliable joint. Can you go back to that? Yeah. Yeah, they two different machines. That top picture kind of shows a electro fusion machine to hook up to it, and the bottom's the butt fusion. So, yeah. Anything else to add there?
I don't think so. I think that's about it.
FRP, I think, yeah, we already kind of touched on that some. Generally, I'll come in plain in pipe fittings and stuff and use the double bell couplings to connect them, but then you can also get flanged, and they are made or fabricated out of the FRP. But then you can transition to other materials, either using a double bell coupling or flange is kind of the main two ways to transition. Probably not a lot to go over there.
Perfect. So one most operators are probably acutely aware of are dresser style couplings. They are available in restrained and unrestrained. You know, these pictures here are unrestrained. They're able to help you with like a size transition. You know, if you're going from say 8-inch pipe to a 6-inch pipe. But also emergency repairs. I mean, these are kind of your go-to if you have a leak. These are kind of your Band-Aid. I'm sure everybody's got a handful of these on the shelf. Like I say, they are getting to where they have some restrained options, but I think probably more common is the unrestrained dresser style coupling. Foster adapters. This is one that we've used a little bit. I know we've specified on a couple locations. It's not something that we typically would put in a standard spec across like a whole project to make it kind of the standard. But what it does is essentially takes two MJ fittings and has a little adapter in between to where you're able to bolt those two together and get those to seal. Where historically without that, if you had two MJ fittings, you know, you had to have your MJ fitting with your follower ring, small chunk of pipe, another MJ fitting with a follower ring. So you've got two joints there, a little chunk of pipe, and a little bit more installation work. In this case, it does a couple of things that are kind of handy in certain situations. It provides restraint. So instead of having that mechanical joint gland really being what's holding you together, you, in a way, almost turn into somewhat of a flange joint, you know, being able to bring those together that way. And the other thing that's nice too, I know we've had projects where we've got, say, like a valve cluster where space is kind of tight, and through installation, especially with larger pipe, with like a flanged fitting where you're going to get a little bit more restraint. You're also a little restricted in construction when you start bolting those together. You know, everything's got to be dialed in just right, where with these Foster adapters give you just a little bit of flexibility at the joint to be able to install.
Flange coupling adapters. So yeah, they're also available in restrained and unrestrained options. Typically used above ground, not really intended for underground installs, although every once in a while we do see them underground. Allows some flexibility when installing the pipe. Don't have to have, you know, exact flange by flange pipe. You can have a flange by plane in and make up a little bit of difference with the flange coupling adapter. And then really helps with removal of equipment. If you have flange pipe in between two valves or elbow in a valve or something like that, can make it difficult to get it, you know, that valve in and out if you had to. So this gives you some flexibility there. There's various types. You know, you got your mega flange and Romac, and those are kind of, you know, the ones we would typically spec. The only main difference there is your Romac's going to have a lot longer lane length than the mega flange. That's one thing you got to kind of pay attention to. I also have a uniflange, but we usually try to stay away from those unless we're kind of low pressure scenarios. Smaller diameter uses the wedge style for restraint that wedge into the pipe. And depending on your pipe material, you get into the larger, and they can use anchor studs where you have to actually drill the pipe, which isn't always ideal. Kind of harder to get them back in place. And just one quick story. I think we're kind of running short on time, but they are restrained, and most of the time I think they hold, but I have seen them blow off a pipe. We had one on an air vac valve. It was a pretty big air vac valve, but they had a large amount of air get into the system. And then once all that air hit this air vac valve that was held onto the pipe with this restrained flange coupling adapter, the momentum of the water hitting the valve and closing the valve after all the air had gone through over time blew the flange coupling adapter off. And after we found it, you could see that every time that air pocket went through, it pushed this up on the pipe, quarter inch or something, until it finally got to the end of the pipe and blew off and made a mess.
Made a big mess, Old Faithful.
Yep. And then dismantling joints, kind of similar, or they can be used in a similar application for, with removal of equipment and stuff. I would suggest if you get into a pipe material or pipe size that gets into those anchor stud flange coupling adapters for restraint, if you can, I would, go with the dismantling joint over one of those. Just helps with reinstalling them. There might be a little bit more expensive than just a piece of pipe and flange coupling adapter. But yeah, it makes it nice if there's a piece of equipment or whatever. If you're going to have to be removing it for maintenance or anything like that, it makes it easy.
So let's
you want me to go, or
go ahead.
Okay. Then we just talk about restraint. Most of the stuff I'm guessing you guys are pretty familiar with. For mechanical joint restraint, you got your kind of lug style or your mega lug that uses the wedges on the pipe. There's also the, ring style that Romac has, the grip ring that we've been seeing more lately, that restrains the pipe and has a basically in contact with the pipe, the tire circumference, and not just on points. You can also use, harnesses, kind of shown on the bottom right, or restrained gaskets like your field lock, or I think Piranha is another one that kind of have little teeth that bite into the pipe. You do want to be careful with the restraint when you talk about PVC. There are special, products made for PVC pipe that, you don't want to necessarily use the ductile iron mega lug on a piece of PVC pipe. It's going to cause some damage. Anything to add?
No, I think that's great. I think we got one more slide here. Like you mentioned, running a little short on time. I think kind of the overarching discussion on restraint that's important is, all of these have the ability to fail. I mean, your air vac valve is a perfect example where just be cognizant of that. I know it's easy to look at, there's manufacturers out there that have pictures of, a pipe restraint holding up a dozer, right, on a crane, and it's, well, yeah, that's foolproof. You can't, that looks great. There's no way you're going to blow that off. But there are cases where you just got to be cognizant of what you're doing there. And then I think the thing we lean on a lot is just a thrust block. They're cheap. They're cheap insurance. If done correctly, they're very effective. And so don't just because you're using a mega lug or have some other restraint types, don't be afraid to also consider a little bit of cheap insurance and a thrust block. And we've got plenty of standard details and can help you with that if you need help looking at that. So anyway, that that kind of wraps up our presentation. I think we're sneaking right up on an hour here. So, yeah, I just for Lucas and I both, thanks for sitting through this. I know this isn't the ideal way to give this presentation, and hopefully soon we'll be back in person and can work through this together. But appreciate your time, and hopefully you got something out of this. So thank you again.
Yeah, thank you.